Hi everyone. In this video, I want to work on a couple more transformations of tangent. I really want to focus in on the ones I think are most crucial to be aware of, and that would be changing your period, so horizontal structure compression, phase shift, and flipping upside down. Those three tend to be the most interesting in terms of what happens to the general shape of the graph. So for this one, right off the bat, I want to be a little bit careful. This should have that factoring involved. Okay, so we would imagine we're starting with that typical, I usually just follow one branch of tangent and then repeat that. So that's one full period of tangent. And normally these asymptotes are at pi over 2 and negative pi over 2. And what I see here is horizontal compression by 1/6, which means my period will go from being pi, negative pi over 2 to pi over 2 is one full period, to being pi over 6. So we want to do that pi divided by b. Remember, it's not 2 pi for tangent, it's pi divided by b. So my period is going to be pi over 6. So pretty small. I do have a phase shift. I'm shifting to the right pi over 6, so I'll say my phase shift is positive pi over 6. So that's actually kind of a boring shift for this one. That's shifting it through a full period. So we can kind of look at what's going on there, but it's not going to make a big difference in how the graph looks. Okay, so let's see. I'm going to follow my asymptotes. So I need to compress them. I divide them by 6, basically multiply by 1/6, and then I need to shift them over pi over 6. Let's see. So this one, negative pi over 2, when I divide by 6, it's going to go to negative pi over 12. And then when I add pi over 6 to that to shift it to the right, I'm going to say, okay, well, that's the same thing as adding 2 pi over 12. So I end up at positive pi over 12. So I think I'm just going to make my grid lines represent pi over 12. So there's 1 pi over 12. 2 of them is a pi over 6. 3 of them is a pi over 4. 4 of them is a pi over 3. Pi over 12s are kind of interesting to count by. They cancel, or they reduce down all over the place. Okay, so I have an asymptote. This one ends up way over at positive pi over 12. If I follow the positive pi over 2, compressing by 6 is going to make it a positive pi over 12. And then if I shift it right by pi over 6, which is a 2 pi over 12, I get 3 pi over 12, which reduces down to a pi over 4. So that little section of tangent I was looking at ends up squashed between here. We can also follow the 0, 0. The compression doesn't move the 0, 0, but the shift does. So it will end up at pi over 6, 0. Other than that, I don't have any vertical compression, structure compression, or shift. So we should just have that kind of typical, let's see if I can make it look. I'm not liking the way mine looks. Okay, so bending down and then it crosses and switches to bending up, something like that. I would love to catch one more period, so let's just go ahead. We know that every pi over 6, which is 2 tick marks for me, we're going to get an asymptote. So there should be one right here at negative pi over 12. If you want to go again, there would be another one here at negative pi over 4. So we're going to have this kind of thing happening. And the same thing here. Always crosses, or the bend changes right in the middle. Okay, so there's 3 full periods of that one. All right, and then last one here is the messiest. So let's check it out. We have flip. So I'm going to picture my one branch of tangent. And it's going to be flipped upside down. We also have, okay, let's do the factoring here. now that I wrote right in my way, negative tangent of pi times, here, I'm going to cross this out. It's not going to fit. Negative tangent of pi times x minus, okay, so if we factor out a pi, it's dividing it out. So it's going to be x minus 1/4, which means we have compression by pi, which is another one of those where that sounds like a really bad plan until you think about what's going on with tangent. That's going to affect my period. So if I do pi divided by pi, my period actually ends up being 1. So I'm not going to need fractions or multiples of pi when I'm labeling my horizontal axis. And then I have phase shift by 1/4. And which way we're going? To the right. So positive 1/4. Okay, so let's see if we put an axis in here. Okay, so no vertical stuff other than the flip upside down. So let's go ahead and follow our pi over 2, our negative pi over 2 and our pi over 2. So if we take the negative pi over 2 vertical asymptote, so that's x equals, we flip it upside down, nothing happens. When we compress by pi, that's dividing by pi, so that's actually going to turn that into x equals 1/2. And then when we shift to the right by 1/4, that's going to turn it into x equals 3/4. So I'm going to make my grid lines 1/4. So this would be a 1/2, and this would be a 1, and this would be a 3/2, and this would be a 2. Okay, so 3/4 is going to be right through here. Let's see, the negative pi over 2. If we do flip, it doesn't change it. If we compress by pi, divide out the pi, we get negative 1/2. And then if we shift to the right by 1/4, that makes it negative 1/4. Okay, so the other asymptote is right here. And then, let's see, 1, 2, 3, 4. So again, you can just rely on some of the nice symmetry that we have here. The inflection point should land right in the middle. But you could also follow it. You could say 0, 0. When I flip, that doesn't move. When I compress horizontally, that doesn't move. But when I shift to the right, it does put it at 1/4, 0. So that's pretty good structure to get me going on one period. Remember, this one was upside down. So we're going to come through, let's see, like this. And again, if you want to follow 1 pi over 4, a negative 1, negative pi over 4, you can. I'm imagining that this is my negative 1 and 1, and I think that's actually pretty accurate that it will cross. If we want to get a second period, we need to go 1 over. So from 3/4, we need to go over to 1 3/4. And then right in the middle, we'll have our intercept and something like that. All right, so there's a graph of that tangent. And let's go ahead and list its domain before we quit with this one. In fact, I skipped that on the last one. We can go back and do that as well. So here, I would say the domain is that x should not equal negative 1/4 or 3/4 or 1 3/4, which is what, 7/4, if I can add 7/4. So I'm just going to pick one to start with. I'm going to go ahead and start at the negative 1/4. Can't be negative 1/4, and it can't be any integer away from that. It's not multiples of pi. I don't want it to be negative 1/4 plus 1 or plus 2 or plus 3 or plus 4 or minus 1 or 2 or 3 or 4. So we're just going to say plus k. K represents our integer, and we'll say that. So can't be negative 1/4 or anything that is an integer away from that. Okay, moving back up really quick before we quit on this one, let's go ahead and look at the domain of the one up above. So here, I would say that my domain is x does not equal, take your pick, let's go ahead and choose pi over 12. And then remember, these were pi over 6 apart. Our period was pi over 6. So we'll say plus pi over 6k, where k is an integer. And it doesn't matter if you make that k pi over 6 or pi over 6k, however you want to do it. You just need a k multiplied by pi over 6. And again, don't forget to specify that it's an integer. All right, thanks for watching.